Hi folks, so after demonstrating in my video yesterday how I can triangulate the position of the Sun in relation to both the flat Earth and the globe Earth models using AutoCAD, I requested that 3 people assist me in taking exact measurements, angular measurements, both azimuth and altitude to the Sun. If it's done in 3 places on the Earth, it can be triangulated accurately in AutoCAD, and we can determine what the shape of the Earth is. I've since researched how you would do this, and it seems like the best way to do it would be to use a Theodolite, a digital Theodolite. So I did a quick search and I found this website in the UK, which is zenithsurvey.co.uk, and they are hiring out a digital Theodolite for as cheaply as £25 a week. Now this looks like a pretty decent bit of kit. And zoom in on it a bit. It actually retails here. You can buy it for just almost £2,000, so it's quite a serious piece of kit. So I think a week is actually probably what you would need it for. I would recommend that if you are going to hire one of these out, you thoroughly research how to use them before doing so that you don't waste your time whilst you've got it. And I'm just going to show a quick video here of someone explaining it pretty well.
And now we're going to measure a horizontal and a vertical angle. We've got 2 pegs in place. We're going to sight to the first peg and then measure or scan the horizontal angle to the second peg. Then I'm going to set the instrument up at 90 degrees and we're going to measure a vertical angle to the corner of the roof.
Great, all right, I'll leave you to it then.
I'm now going to scan an angle between the 2 pegs. I'm going to set the instrument up on the nail in peg number 1 behind me and zero the instrument, and then I'm going to turn the instrument round to peg number 2, center on the nail, and then read the scanned angle on the digital display. So, turning on the instrument and zero setting the display. Now centered on the nail on the second peg, and I have a scanned angle of 41 degrees, 20 minutes and 55 seconds. I'm now going to shoot a vertical angle from the horizontal to the corner of the roof on the adjacent building. I'm turning on the instrument and bringing in the vertical scale. It will automatically come in with the instrument at horizontally at 90 degrees. So when I then read to the corner of the roof, so I'm reading to the bottom of the fascia, I now have a vertical angle on the display of 82 degrees, 53 minutes and 25 seconds.
So this was part 4 in a short video series that these 2 guys have done. The first 3 show you exactly how to set up the Theodolite and how to position it correctly. That I recommend that you watch all 4 of them from start to finish so that you know what you're doing. So you may be wondering how you're going to actually point this thing at the Sun and be able to see it without burning your eyeballs out. Well, I bought this solar filter for telescopes a couple of months back for attaching to my camera here so that I could film the Sun. And they come in various different size sheets. This one was a 4" by 4" sheet. I'll show you where I got it from in a bit. Not expensive. And all I did was I had this old sort of tube lying around, this black tube, and I screwed with some tiny little black screws there this solar film to this tube. I wasn't that pleased with the job I'd done of it, to be honest, because it was a bit wrinkly, but it doesn't affect it at all. It works perfectly. And all I did was placed it over the camera lens here and just put a little bit of sellotape across the top here so that I could sort of hinge it backwards and forwards easily for sort of quick access, and I'll show you some of the footage that I took with it. So this was viewing the sun through my solar filter on my camera. Now, this was a couple of months ago when I first got the camera, and I didn't realise that it had a auto stabilisation function on the camera, and it tells you that if you're using a tripod you're supposed to turn this function off, which I didn't. And it keeps trying to auto correct itself and try and stabilise the image in the middle of the screen. Couldn't be helped at the time, I'm afraid, but it's not too bad. And as you can see, as I zoom further in and the sun turns like an orangey red colour, it turns into an absolutely perfect circle. So I believe that using the crosshairs that you see through the telescope on the Theodolite, even though it is completely pitch black when you look through this solar filter, like if I try to look at a fluorescent light, or if there's any haze in front of the sun, it blocks it out, it's just black. But since the sun is so bright, when it's not obscured by haze, I think the crosshairs on the Theodolite will come through quite well, and you'll be able to get a perfect centre, or near perfect centre, of the sun. Now I've chosen the sun specifically because it's out every day. We could choose the moon and we wouldn't have to bother with this solar filter, but there's a lot of waiting around to do for days, and if you hired a Theodolite, you want to make proper use of it. But if anybody wants to do the moon, then they're perfectly welcome. I can still triangulate the results. I would ask, if you're going to do this, to video as much of it as you can as possible. So once you've taken all the angles on the Theodolite, you video them, the digital display. If you could have a GPS device with you that you can place on the ground and just video that to verify where you actually are. And also, if you can try to put your video phone camera lens to the eyepiece, because your video phone lens is so small, you should be able to get a view of what the Theodolite's seeing. That would be good if you could get that. And what you've got to do is ensure that you are exactly pointing due north when you take the first reading to measure your azimuth angle from. You need to calculate for true north as well once you've done that, because there is a variation. You've got to be quick when you do this, because the sun, believe it or not, moves pretty quickly. And I would also say that you should take a few practice runs at this as well before actually you taking the proper readings. So I'll show you now where to get the solar filter from. So I got it from Amazon. So it's just a 4" by 4" solar filter. It cost me £6.50 and it was £3 delivery, so under £10 for the solar filter. So with the Theodolite at £25 for the week and the solar filter at just under £10, that's just under £35. I think it's a pretty good price really. There's probably a bit of delivery on that as well for the Theodolite, unless you can pick it up. But yeah, I think it's a pretty cheap price to get some pretty good results. So if you want to drop me a line, my email address is neomagic@sky.com. So if you want to get in touch with me, just email me. Thanks for watching.